Hey, this is Mr. Preston. We're going to be dividing radicals now. So what you'll see is we have one radical expression divided by another. Now we cannot have a radical or a square root on the bottom. So what we're going to do here is we're going to try and undo it. We're going to try and get rid of this square root of 3. So the easiest way to get rid of the square root of 3 is to multiply it by itself. If I do that, then I have square root of 3 times the square root of 3, which is just the square root of 9, which becomes 3. And then I don't have a square root anymore. So that's what I'm going to do. I'm going to multiply the top and the bottom by the square root of 3. I'm going to end up with 2 square root of 6 over, by the square root of 3, over the square root of 9. Okay, and the square root of 9 simply is 3. So I have 2 square root of 6 over 3. Now let's see if I can simplify anything else. 2 over 3 is simplified. The square root of 6, I can't pull anything else out of the square root of 6. So that's as simple as it's going to get. Let's try another one. Say we have 5 over 2 square root of 2. So this is called rationalizing the denominator. We're simply getting rid of the square root that was on the denominator. We're doing this because when we get to special right triangles, we're going to have situations where we have 3 over square root of 2 or 5 over 2 square root of 2, and we can't leave our answer like this. We have to make sure that the denominator, or the bottom, does not contain a radical. Okay, so that's why we're doing this. So here, I have 5 over 2 square root of 2. So I need to make sure I understand what's in my denominator. My denominator here is 2 square root of 2. So I'm going to multiply both the top and the bottom by 2 square root of 2. So I multiply across, I get 10 square root of 2 over 4 square root of 4. Okay, so the square root of 4 is simply 2. Remember, this is 4 times the square root of 4, so 4 times 2. This becomes 10 square root of 2 over 8. 10 over 8 reduces to 5 over 4, because 2 goes into both 10 and 2. So 10 divided by 2 is 5. 8 divided by 2 is 4. So this reduces to 5 over 4 square root of 2. So that right there is our final answer. And you'll notice the denominator no longer contains a radical, and the square root of 2 cannot be further simplified. Let's do one more. Let's say we have, the square root of 6 over 3 square root of 15. So first thing you got to do is identify what your denominator is. Understand that it has a radical, a square root, so we need to undo that. So I'm going to multiply the top and the bottom by whatever my denominator was. In this case, it's 3 square root of 15. I end up with 3 square root of 90. Write this down here. So 3 square root of 90 over 9 times the square root of 225. Square root of 225 is simply 15. So this is 3 square root of 90 over 9 times 15. So 9 times 15, 10 times 15 is 150. So 9 times 15 is 15 less, which is 135. So I have 3 over 135. So both 3 goes into 3 and 135. Well, how did I know that 3 went into 135? If I add the digits, 1 plus 3 is 4, plus 5 is 9. And if that's divisible by 3, then the entire number is divisible by 3. So this can simplify to square root of 90 over 135 divided by 3, which is 45. Okay, well, are we done? Almost. The square root of 90 is not simplified. So this becomes the square root of 9 times the square root of 10. So this is equal to 3. Let's see, make sure I'm still on the screen here. So this is equal to, I'll write my final one over here. 3 square root of 10 over 45. And so right here, 3 square root of 10 over 45. 3 can go into both the top and the bottom. So 3 divided by 3 is just 1. 45 divided by 3 is 15. So this becomes square root of 10 over 15. And that is my final answer. So that one took a bit longer. What caused it to take longer is just the fact that we had to break down the square root of 90. Okay? And we had to reduce fractions a couple of times. So that is dividing radicals.